Hello viewers, in continuation with the previous programs, in this program we will continue to explore the concepts of control statements in C++ programming language. Iterative control statements. In the start of the series, we discussed an example of a person who wants a 5-kilometer morning walk on 1-kilometer walking track. Let us take another example. Suppose you want to count number of blue colored cars in a showroom. How will you do this? My dear, you will simply go for each and every car in a showroom and check if it is of blue color and increment your counter for counting blue cars. But have you noticed you are simply repeating the procedure for color checking and incrementing counter? Or you can say that a loop is formed for both the procedure and it will be repeated till you have checked all the cars in showroom. Technically, we can say that a loop indicates ability to repeat some portion of the program either for a specified number of times or until a particular condition is being satisfied. Thus, a loop makes a sequence of statements that are to be repeated. Once a loop begins to execute, it will go on forever, but there must be some way to stop iteration process. Hence, the conditional statement that controls the number of times a loop is to be executed always accompanies loops. Such type of loops are iterative control statements. The following three types of loop structures are supported by C++. These are for loop, while loop, and do while loop. Let's discuss them in detail. For loop. It is the most commonly used loop. For loops are used where a programmer knows when to start a loop, that is a starting point, and when to finish loop, that is test condition. Suppose we want to print numbers from 3 to 8. In this case, we know that first number to be printed is 3 and last is 8. Means after printing number 8, program should stop. Every number has to be incremented by 1 only. Thus, we can say that for loop has specified list of expressions which control variable in the loop. It consists of 4 elements. Initialization expression, it is used to initialize the index value. Test expression, index value is tested so as to check whether or not to continue a loop. Body of the loop, and then is update expression. It changes the index value of further alteration. The syntax of for loop is as shown on the screen. The same thing can be explained with the help of a flowchart. Here we can see that after the initialization, body of loop is executed till test condition is true. Now let's explain the same with the help of a program to find the sum and average of any 10 numbers. Can you notice where the for loop is formed? In this loop, you can see that I is the running variable and is initialized by 1 with the help of an initialization expression, that is I is equal to 1. It is tested for test condition, that is I is less than equal to 10. Since for the first time I is less than 10, so the flow of control is transferred to the body of loop. It will prompt the user to input a number and add it to sum. Then I, that is running variable, is incremented by a step of 1. That means this is update expression and new value of I is again checked for its test condition. Thus, if 10 different numbers are entered through keyboard, then their sum and average are 55 and 5.5 respectively. So this is the way how a for loop is executed. Next, we will discuss about 2 other forms of loops. Do while loop. This is another type of iterative control statements. This loop evaluates the condition at the bottom of the loop after executing the body statements. It consists of 4 elements. Initialization expression, it is used to initialize the index value. Body of the loop, update expression, it changes the index value of further alteration test expression, index value is tested so as to check whether or not to continue a loop. The syntax of do while loop is as shown on the screen. From this syntax, it is clear that do while loop executes at least once even when the specified condition is false. The same thing can be illustrated by flowchart. You can see that initialization is done before the loop starts, updation expression is within the body of the program, and test expression is evaluated at the end. Now let's explain the same with the help of a program to find the sum and average of n numbers using do while loop. We are going to sum any k numbers and then find its average. After including header files and declarations, user here is prompted to input for how many numbers are to be added. Suppose he says 5, then loop will be executed 5 times. Within body of loop, you have to input the number to be added to this sum, and then increment running variable by 1. See the beauty of this language. You can declare a variable wherever it is needed. It is not necessary to declare all the variables at the start of the program. This loop is executed till I is less than equal to k, and at the end prints sum and average of inputted numbers. So have you noticed how the same loop can be constructed in do while format? Now enjoy writing C++ programs with do while loops. While loop. Till now we have learned how to use for and do while loop. Now we will discuss about while loop. While loop repeats a set of statements until the given condition is true. It consists of 4 elements. Initialization expression. It is used to initialize the index value. Test expression. Index value is tested so as to check whether or not to continue a loop. Body of the loop. Update expression. It changes the index value of further alteration. The syntax of while loop is as shown on the screen. The body of loop will be executed only if the initial condition is true. Thus, the number of times loop will be executed is not certain. Same can be presented by a flowchart also. You can see if the test condition is false, loop is not executed at all. Now let's try to write a program with while loop. It is a simple program to print numbers from 1 to 5. Here the initialization expression is count is equal to 1, test condition is count less than equal to 5, and body of loop prints the value of variable count and also update value of count by count plus equal to 1, or in other words count is equal to count plus 1. Thus we have seen how different formats of loops can be used in situation where repeated work is to be done. Can you differentiate between while and do while loops? Just have a glimpse of it and try your hands in drafting some C++ programs having loop structures. Difference between while and do while loop. The syntax of while and do while loop is as shown on the screen. The while is an entry controlled loop and do while is exit controlled loop. While tests the condition at the beginning of the loop and do while checks the condition at the end of the loop. In while loop, if the specified condition is false, the body loop will not be executed. In do while, the body of the loop will be executed at least once even if the specified condition is false. Transfer control statements. Till now, we have seen how to craft decision-making programs beautifully with the help of control statements. All those control statements are very systematic and organized. The flow of control is transferred to other pieces of program in a very structured way with one entry, one exit policy. But real life is not so smooth. Sometimes we have to break the rule of structure. we have to abruptly transfer the flow of control to some other part. For example, suppose you are at some hill station for your vacations for 10 days. You are enjoying with your family and suddenly some urgent call comes from your office and you have to rush to office without enjoying your vacations. That means the iterative process of enjoyment has been suddenly cancelled because now you have to do some other work. Let's take another example. Suppose a potter paints 20 pots a day. He continues painting one pot after the other and suddenly one pot breaks. Potter has to leave that pot and continues with other pots painting. That is, the potter skips painting of the broken pot but continues same work till all pots are painted. Such type of real life problems can be solved using transfer control statements in C++. Let's discuss each transfer control statement one by one. Goto. The goto statement transfers the program control anywhere in the program. Its syntax is as shown on the screen. The target destination of a goto statement is marked by label and goto must appear in the same function. Label is a user supplied identifier and can be placed either before or after goto. In goto statement, the transfer of flow of control is unconditional. So these statements S1 and S2 will be repeated infinitely, thereby creating an infinite loop. Thus, in the first example, ordered set different values of A will be printed infinite times. If we want to stop this process, we must accompany goto statement with then if statement. The example is as shown on the screen. In this example, values of A will be printed from 1 to 50. Thus, it is equivalent to do while loop. Break. Sometimes the situation demands an abrupt exit from a loop without waiting to get back to the control statement. Break statements can implement such abrupt exits. When the keyboard break is encountered inside any loop, control automatically passes to the first statement after the loop. In switch statement, it is used to indicate the end of case. The syntax of break loop is as shown on the screen. We can use break statement in all kinds of loops as well as in if condition. Let's see the working of break statement in all the loop statements. First of all, we will take while condition. You can see within a loop statements S1 and S2 are executed. Under normal conditions, loop will be executed till expression is true. Statement S3 will be executed only after the successful completion of loop. But if test condition within loop is evaluated as true, break is executed and flow of control is transferred to S3 statement. Similarly, for loop is executed successfully till test condition is evaluated as false, or abruptly it can come out of loop by a break statement, which is executed if and only if this if condition within loop is true. Here also control will come out of loop to S3 statement. In the same way, we can see how break affects a do while loop. In all the three cases of loops, statement S1 is executed within the loop, then if condition is evaluated. For successful execution of condition, the control will come out of the loop and execute statements S3. In case of failure, statement S2 is executed and loop is continued. Now let's see how break is used with selective control statements. Within a if block, all the statements from S1 to S5 are executed sequentially if condition 2 is false, but if condition 2 executes to true, then statements S4 and S5 will not be executed within a block. switch case. In switch case statement, the break statement signals the end of particular case and causes execution of the switch statement to be terminated. The syntax of switch cases as shown on the screen. Continue. In some programming situations, we want to take the control to the beginning of the loop by passing the statements inside the loop, which have not yet been executed. This can be implemented by the keyword continue is encountered inside any loop. Control automatically passes to the beginning of loop. It is usually associated with if statement. For while loop, the working of continue statement is as follows. You can see the flow of control is transferred back to loop. For loop, the working of continue statement is as follows. And for do while loop, the working of continue statement is as follows. You can notice that in all the three cases of loops, statements S1 is executed within the loop, then if condition is evaluated. For successful execution of condition, the control will come back to testing condition of loop, thereby skipping the statement S2. In case of failure of if condition, statement S2 is executed and loop is continued. The statement S3 is executed only when the loop condition is not satisfied. Thus, keyword continue skips the rest of the loop statements and causes the next iteration of the loop. So friends, I hope you are much relaxed now and can convert any real-life problem to simple C++ program. Now start enjoying programming in C++ as you learnt much about variable declarations, constants, scope resolution, data type and various control statements. Thank you for watching this program.